Hey, what's up, guys? Thank you very much for being on Electrica. I really appreciate that. Thank you for subscribing. If you're new here, you're welcome. This is Electrica, and we talk about electrical stuff. My name is David. Thank you very much. Now, today I have an interesting topic: changeover switch. Changeover switch. It's very interesting in that it plays a very significant role in our, power usage today. Okay. So many people out there, they need constant power supply at all time, okay? And to do that, you need a changeover switch, such that if your utility power supply sheds, then your main power or your alternative power comes in, okay? But how does it come in? By use of changeover switches. And these can be either manual or auto. Okay, and we talked about manual changeover, and the manual changeover looks like this. Of course, what you're seeing out there might not be exactly this, but it will look like this, where you have, where you have two positions here. You have 1, 0, and 2. So if your power sheds, you just come and move it from one position and to the other position. Okay. The alternative power could be generator, could be solar when you're using an inverter, or anything else, okay? But I felt like we can talk about auto changeover, and as the title reads, what you need for your changeover switch. I know many of you out there, you love to build your own because it can be really costly, okay? So, before we go any further, I need to stress something. Now, since we are talking about changeover switch, what we're going to do is today, let us talk about what you need in details for that changeover switch. Then we can, bring the next video to explain the wiring and the wiring diagram, or we can put a control diagram and power diagram so that you are able to understand that. Then the other one, we can do a practical video now, okay? That will be great. All right. Now, since we're going to talk about auto, there are some, devices, components that you're going to need for you to have this fully function automatic changeover. And one of those, you of course need contactors. Okay. Of course, since you're changing from main to generator, you need 2 contactors. Okay. And any contactor will do. What matters is the current demand for your supply, okay? So if you calculated it and you know your current demand, then that will give you the size of your contactor, okay? Then the other thing is that you're gonna need a phase monitor, okay? You're gonna need a phase monitor, which looks like this, and this phase monitor plays a very significant role in this system. So, most of our powers are not really, stable. You have variation in these phases all the time. Power keep on fluctuating, and that's not good really for your, for your gadgets and your installation. So that's why you need a phase failure. You can do without it, but in these modern days, you have to do what it takes to keep your installation, safe. So you have this, it's a 3-phase phase monitor. It's 2-way, it can work either way, single phase, 3-phase. And what will help you is that it will take in the 3-phase supply. So, and it has got some parameters here, over voltage, under voltage, okay? And that will give you, a chance to monitor all these parameters. If your voltage goes down at a certain threshold, it cuts off power. If it goes up, certain threshold, it cuts off power, okay? So, you understand that. And yes, it will help, okay? All right, so the other thing that you also include in that, number 3, that will be a relay, okay? And by the way, for phase monitor, you only need to connect a phase monitor on the main supply, because most of the generators that come, they already have these kind of devices equipped with it inside its car, okay? All right, now, you need this guy here, a relay. So most of the gadgets I'm talking about here have individual videos for them. I'll put all the links in the description, okay? So a relay is here. So you have a relay here, and this relay also plays a very big role. Remember when we talked about a relay in our previous videos, we talked about the role of a relay, okay? Because it has multi-contacts, so you can use it what you want. So in this case, in the generator, there is a time when the power goes and then you need to send a signal to the generator to start. So we use a relay to do all that. And also we use it for interlocking, okay? For, double interlock, we do that, okay? So, but the other also crucial role is that you have a timer, okay? That I'll add here. You have a timer, and this timer, it's a delay. It's a delay timer, okay? Now, let me give you an example. If your power is normal, working normally, and then it goes off. So when it goes off, the generator will come in, of course. It will earn the signal, and then it will come on. So when it comes on, we don't want to load that generator instantly because it will start on load. So that's why you put a timer to delay it. But hey, look. So that means that this timer, it's actually supplying the gen contactor, okay? Because when the gen starts, it will give it supply, okay? So that means that without a timer, you will be supplying the gen contactor directly, okay? And that means that it will start on load. That one will, run your load, but also it's not healthy for a contactor, okay? And also, so this timer is weak. The terminals are very weak. They can't supply a contactor. If you have a contactor like this one of 30 amps, it's okay. This timer can handle. But what about if you're supplying a contactor of around 150 amps or 100 amps? So you'll need to use the timer to supply the contactor, and then the timer will supply the relay. Okay? All right. So these are the main components that you need to, to construct the changeover switch that we're going to do in a few days to come. Okay? So, match on the phase monitor. So, there is also this is a phase monitor also, but it doubles as a sequence monitor. Okay? So, if you have any drive, like you have a 3-phase drive or a pump, which you know that it will be affected by the direction. So instead of using this, you can use this that it has a sequence, so to protect it. Because if your pump, your tutor supply changes the lines, and then your system will reverse. So that doesn't affect all other things apart from the drives, the motors. Okay, so if you put this, then it will not allow power to come. It won't connect the circuit on. So you are able to look at that. You can either call the tutor supply to help you with that, or you can interchange the phases in your system. Okay? All right. So go to the comment section and tell me which one of these devices you didn't understand. Okay? Because in our next video, we are going to incorporate them in a circuit, and you really need to be following attentively. And then the other video, we are able to do a practical video, okay? So, we have a contactor 2, we have a phase monitor, we have a relay that will have 2, and then we have a timer that will be 2 both sides. So, that will really help. So I hope this video has been of a help to you. Thanks for watching. I really appreciate that. If you're new here, please feel free, subscribe, like, and share. And share to only those people whom you think that this kind of, content, makes sense to them. Okay? So until next time, I really appreciate that. And by the way, guys, it's a disclaimer kind of, when I bring these videos, you need to pay attentive and understand them very well, so that when the next video comes, you're really good. okay, you're able to understand everything. Because some people really come, the comment section and ask me a question on the very video, and yet the answer was, forward a bit. So they watch some few seconds and then they ask us a question that is really answered in the video. Okay, so sometimes I look at those questions there, I just leave them hanging. I might not answer them back because they didn't watch the video to full. Okay, so thank you very much. I appreciate. Please don't forget to subscribe, like, and share, and sharing to one of those people whom you think that this kind of content will do them good. So thank you very much. Until next time, I'm out. Hey, what's up, guys? Thank you very much for being on the lecture. I really appreciate that. Now, today I'm giving you the wiring diagram of automatic changeover switch. And I told you in a previous video where we learned about the device that comprised in a changeover switch. Okay, so you learned about all these devices. Now let's understand the circuit, how it flows. I know you asked me for a practical video, which is coming after this one, okay? But even if I did, practical video earlier, still you wouldn't understand, most of you, per se. You need to understand the circuit first, such that if, I'm doing that video, not many comments will come that what is this, why did you put this wire there, why did you pass this one there, and here, you understand? So we have to understand the circuit. That's my purpose goal. I really want every person that watches this video that can really, understand, not cramming, but understanding the really, flow of current in this circuit, okay? So that you can understand the control very well. Okay, so you bear with me. So we are having this control circuit of a changeover switch. And this is a three-phase changeover switch. So you have two sources of power. You have your main utility supply and you have your backup generator, which should start in case your main power supply sheds, okay? So right here we have two circuits which are not complete. We will complete together, okay? So this is the part up here is the main circuit, okay? And then the part below here is the backup or the gen circuit, okay? All right, now let me show you such that we can understand very well. Okay, so circuit number one, the main supply, the main circuit, you have a timer here, you have a relay, okay, and then you have a contactor, all right? So circuit number two, you have a timer, you have a relay, and you have a gen contactor, okay? So let's start from the upper one. Now, so the first breakers here, these are circuit breakers. The first three breakers here are, control breakers, and they supply this because we need to put three-phase here to be monitored by this gadget here, okay? So all of these, they are entering our phase failure, okay? They're entering our phase monitor. Right here, this is the normally open of your phase monitor, okay? All right, and then you have a timer here. The first thing, you have a timer here, you have a relay one here, then you have a contact of relay 2 and a contact of auxiliary 2. Now this auxiliary is what you're seeing on your screen. It's on every contact, and that's why you see here we have aux 1, auxiliary 1, we have auxiliary 2. This auxiliary 1, it's mounted on contactor number 1 or the main contactor. Auxiliary 2 is mounted on this contactor here, the same way you're seeing in that picture there, okay? So let us move the wires. Now we have our control breaker here, okay? That's our control breaker. that has gone into normally open of this monitor relay, okay? All right, now right here, we have to supply the coil. This is a coil of the timer. So we supply the coil, and then you can still rip a wire here and supply the open contact of the timer, okay? So this is N. Our control circuit is single phase, 240 volts. Okay, it could be 110 where you are, or 230, but here we use 240. Then through this timer here, if it closes, our coil here gets supply of R1, and then the same time, we loop to that contact, to any contact normally open of the relay. Okay, normally open of the relay. Now, this is a neutral, okay? So, from the R1, we have to go through R2, okay? This is R2 right here. We have to go through the R2. R2 is the relay for the gen, okay? So, from right here, we are going through the relay of number 2. Now, from the relay, we'll go through the opposite 2 of this gen contactor. And now, lastly, we go to the contactor coil, okay? And that's a neutral. All right? All right. Now, that's number 1. So if we come to the gen, we always have, this breaker here, the control breaker. Now on generator, you see that we don't have a phase monitor because all this supply that comes that side is clean, okay? So right here, we will just supply the relay, and from the relay, we supply the normal open of the, sorry about that. From this breaker here, we supply the timer of the gen, and then we supply also this contact here, such that when the relay is given power, it will close this, okay? Now, through the timer, we go through R1, this R1 here. We go through it, okay? And then, through R1, we supply this relay R2, okay? And then, of course, supply contact normally open. And then before we go to the gen directly, we have to pass through the auxiliary contact of the main, okay? All right, now let me explain. Now this is our main. Now you see that from the control breaker, these are 4 breakers. The 3 breakers are carrying the 3 phase, controlling the 3 phase that is entering the monitor relay, and then this is a control breaker. So our current move through the normal open of the monitor relay, okay? You see, through the normal open. Now, under normal circumstances, the power supply, of course, you supply the coil of the relay will get energized, we close this one, and it energizes the timer. The timer closes its normally open, and then current goes through it, it supply the relay number 1, okay? Relay number 1 also closes its normally open contact to close, and then the current will flow through relay number 2 of the gen because it's not closed, okay? It's open, it's not energized. So meaning that these contacts are closed. So we go through contact of the gen, opposite 2, and then to the coil. And now we'll have generator supply, main power supply here, our contactor will get engaged. Okay? So the reason why we have these 2 here is for the purpose of protection. This is what we call electrical interlock. Okay? So there are 2 simply because 1 can fail, okay? So that's why we have to pass through R2 and then opposite 2 before we reach this main contactor here, okay? All right. Now, let me say that if the power goes, and shades right now, power goes off. When it goes off, it means that all these, they will be energized, okay? And when they do so, there is what happens. So our generator So our generator, I'll show you that in a practical video. Our generator starts with a signal, okay? So this generator, let me explain something. When you're on your generator, you can press start, okay? And then it starts. So that's where we link the cables that comes to this changeover. And it's just one cable here. So it's like a switch. If you short, or if you complete a circuit in that switch, definitely, because the moment you press, you're completing a circuit, the generator starts. So that's the cable that comes here, the positive, okay, that comes in our changeover. So we drive that one cable. And that cable, we connect it in a relay, okay? That one I'll show you in a practical video. In a relay. Relay has many contacts, okay? So if this power goes through this R1, because it will closes, it will send a signal to the generator, okay? The generator will start. And when the generator starts, our current will move right here and supply the timer here. And this timer will close it's normally open, and then it will go through R1, because R1 is de-energized. This is closed, so it will go through here, and then it energizes its R2 here. Then R2 will close its contact here, but before we reach the coil, we have to go through the auxiliary contact of this main contactor, because it is it's de-energized, so this is closed. Our gen will get the supply. Okay. Now, if our generator is running and this circuit is on, is engaged very well, you remember there is something we said about, okay? Something we said about priority, okay? So if the main comes back, we give it the priority, okay? That means that if the main comes back, well, no matter what, it has to take over and engage its, the main circuit, and the generator will go off. Let me explain that. Now, right now, let's say that the generator is running, okay? The generator is running, this is closed, and the gen is running. So, if power comes back in the main circuit, our relay here, the monitor relay, will close, okay? And it will supply the timer right here. You understand? And the timer will close, it's normally normally open, and then they will supply relay number 1. So you see here that the moment this relay number 1 gets supply, it closes here and it opens, okay? It opens, it's normally closed contact. And remember, that's where we passes our control of the generator to the coil. So if this relay energizes, it means that it cuts off power from here. Okay? So the contactor will lose. And if this contactor loses, it means even the relay number 2 here also loses power. Okay? So it means that these two contacts which were open while this one is operating, they will become closed again and our main will engage. Okay? Hope you understand that. And so that means that the moment this one open, the circuit will be off, but now our generator will be running still. But remember, the signal that control the generator on off is from this main relay. Okay? So if the relay get energized, it means it will cut off the supply. So the generator will sense that and it will go off. All that happens the generator card. Okay? And you will see that in the practical video. I promise you. Okay? Alright. So I hope I made sense here. I hope so. And if you really don't understand anything, you should tell me. I tried to simplify this circuit as much as possible, such that even if a person is lay, most of the things here can still understand that. Okay, the way I drew this circuit here, it's really very easy to understand. Okay, all right. So we'll recap one thing. The moment what you're seeing here is that in your control, on the main, on the side of the main, you have 4 breakers, one for control and the others for relay, for the monitor relay. Okay. Okay. In my previous video, where I was talking about these components, okay, there is someone that asked me a question that what can this circuit operate, or can you do without this relay? Okay, I'll answer you in this video by saying that it's really hard to to avoid the relay, because this relay is serving many purposes here. First of all, this relay, it's helping us to interlock. We're using them as second interlocks. Secondly, the very relay is also helping us to to send the signal that side to the generator. And you're going to have so many things here. You will have indicator lights. Okay, you have a signal generator. You want to make electrical interlocks. You understand? So you cannot do all those without the relay, because they have many contacts. You cannot do that on all of them on the contactor. Okay? So hope that answers your question. Thank you very much, very, very much for watching. I will appreciate that. Thank you very, very, very much. Now, if you're new here, my name is David. Please, if you find value here, don't forget to subscribe, to like, and share. And sharing, I mean that if you have any person, any friend, any relative that you really have interest to learn this kind of content, then why not to share? Okay? Thank you very much for watching indeed. Until next time, I'm out. The practical video will come next. I'm out.